Every now and then you hear about marvels created by humans in the field of space. From the moon landing to the International Space Station and the plans of Mars exploration. All are possible only because of the development of rockets. This working principle behind rockets is very simple. A special fuel goes under combustion, creating a large amount of exhaust that is passed through a nozzle which produces enough thrust to lift the payload. This remarkable invention has helped human beings explore the universe we live in and land on to heavenly bodies other than the Earth. The evolution of space technology has come a long way since Greek philosophers were first interested in astronomy and space in the 1600s. However, the foundations of spacecraft date back to the 11th century when the Chinese developed the first known rocket. This rocket was very similar to what we know today as the firework, and it is the substructure for modern-day liquid propulsion rockets. The fire arrow was a paper tube filled with gunpowder that exploded when lit. These rockets were used in war and they were presented to the Empress of China like a firework show. Moving into the 12th century, the Chinese further developed these rockets by attaching them to mounts, keeping the tube intact and shooting a flame about 20 meters. However, the idea for the first space rocket was pitched by a Russian school teacher, Konstantin Sawatsky, in 1898. In a research paper published in 1903, Sawatsky suggested the use of liquid propellants for rockets in order to achieve greater range. Sawatsky stated that speed and range of a rocket were limited only by the exhaust velocity of escaping gases. For his ideas, careful research and great vision, Sawatsky has been called the father of modern aeronautics. Early in the 20th century, an American scientist, Robert H. Goddard, conducted practical experiments in rocketry. Goddard's earliest experiments were with solid propellant rockets to measure the exhaust velocities of the burning gases. While working on those solid propellant rockets, Goddard became convinced that a rocket could be propelled best by liquid fuel. But it was a much more difficult task than building solid propellant rockets. For such a rocket to be built, fuel and oxygen tanks, turbines, and combustion chambers would be needed. In spite of the difficulties, Goddard achieved the first successful flight with a liquid propellant rocket on March 16th in 1926. Fueled by liquid oxygen and gasoline, the rocket, however, flew for only 2.5 seconds, climbing 12.5 meters and landed 56 meters away. Goddard's experiments in liquid propellant rockets continued for several years. His rockets became bigger and flew higher. He developed a gyroscope system for flight control and a payload compartment for scientific instruments. Moreover, parachute recovery systems were also added by him to return rockets and instruments safely. Goddard, for his achievements, has been called the father of modern rocketry. With the advent of the Second World War, the Germans worked day and night to build formidable rockets that could destroy London and the Allied forces. They succeeded in building one such rocket named the V2. Built under the guidance of German scientist Hermann Oberth, the V2 used liquid oxygen and alcohol at a rate of about 1 ton every 7 seconds. Once launched, the V2 was a formidable weapon that could devastate whole city blocks. Fortunately for London and the Allied forces, the V2 came too late in the war to change its outcome. After the end of the Second World War, most of the German scientists moved to the United States, while the rest to the Soviet Union. Both the United States and the Soviet Union realized the potential of rocketry as a military weapon and began a variety of experimental programs. At first, the United States began a program with high-altitude atmospheric sounding rockets, one of Goddard's early ideas. Later, a variety of medium and long-range intercontinental ballistic missiles were developed. These became the starting point of the US space program. On October 4, 1957, the world was stunned by the news of the launch of Sputnik 1, an Earth-orbiting artificial satellite by the Soviet Union. The satellite was the first successful entry in a race for space between the two superpower nations. Less than a month later, the Soviets followed with the launch of a satellite carrying a dog named Laika on board. As they passed, the space race between the two superpowers created a massive boost in the development of rocket technology. Soon, the scientists were able to develop smaller and more powerful rockets that could power heavy payloads, such as a space shuttle. The Soviets won the space race by sending the first man into space in 1961. Yuri Gagarin, a Soviet Air Force pilot successfully orbited the Earth and landed back in the Atlantic Ocean, creating history for the mankind. Rockets became an extremely important part of the military as modern intercontinental ballistic missiles could carry nuclear weapons on a rocket vehicle, which were essentially impossible for existing defense systems to stop once launched. And launch vehicles such as the R-7, Atlas and Titan became delivery platforms for these weapons. Fueled partly by the Cold War, the 1960s became the decade of rapid development of rocket technology, particularly in the Soviet Union and in the United States. This race was partly won by the US when the Apollo 2 program took off in the year 1969 that used the Saturn V rocket. The spacecraft held 3 men and they landed on the moon, making them the first astronauts to set foot on the moon. The landing on the moon was a monumental step in space exploration, and it opened the door to more efficient and safer human transportation to space. In the late 20th century, rocket technology became sufficient enough to transport payloads of several tons of weight. The rockets were now developed as multiple-stage propellants and also used boosters to increase the thrust significantly. This allowed the scientists to send rovers and satellites to Mars. NASA's Space Shuttle program from 1981 to 2011 used solid rockets to send humans into space. The shuttle itself had 3 liquid-fueled engines with 2 solid rocket boosters strapped on the sides. However, a drastic event happened in 1986 when a solid rocket booster zero ring failed and caused a catastrophic explosion, killing 7 astronauts aboard the Space Shuttle Challenger. The solid rocket boosters were redesigned after the incident. With the inclusion of liberal space laws, private players came into rocket technology. Of all the private companies, SpaceX developed some of the best and most powerful rockets known to mankind. The Falcon series rockets revolutionized the rocket industry by bringing the cost per launch to much lower than the earlier space agencies. The Falcon 9 rocket created history when it delivered Dragon spacecraft to low Earth orbit and then safely returned its first stage back to Earth for a vertical landing. In recent years, rocket technology has become more and more advanced with the inclusion of India's space program that is perhaps the most efficient in terms of cost per launch. The PSLV series of rockets developed by the ISRO holds the record for the successful launch of the most number of payloads in a single mission. It is also supposed that due to the increasing competition and development in the field of physics, humans will soon be able to build more powerful rockets that would be cheap enough to transport payloads to Mars and other distant heavenly bodies. This was all for this video. Thank you for watching.